June 30th, 1908, the Central Siberian Plateau. A column of blue-white fire crosses the sky for hundreds of kilometers. 7 minutes past 7 in the morning, local time, the sky tears open. 80 million trees, flattened in a radial pattern across 2,000 square kilometers. Reindeer killed in their pastures. Glass shattered 600 kilometers away. Atmospheric pressure waves recorded as far as London. 3 questions remain. What kind of object can release the energy of 1,000 Hiroshima bombs and leave no crater? Why did it take 20 years for Soviet scientists to even reach the impact site? And why, more than a century later, did NASA finally publish an answer that the Tsar's astronomers had no way of imagining? To understand what happened on June 30th, 1908, you have to understand where it happened. The stony Tunguska River, Krasnoyarsk Krai, Central Siberia. A region of taiga so remote that the nearest reasonably equipped town, Vanavara, was 65 kilometers from the epicenter. St. Petersburg, the imperial capital, was 4,000 kilometers to the west. The witnesses were not astronomers. They were Evenki reindeer herders, traders, peasants, and a handful of Trans-Siberian railway engineers far to the south. One witness, Semyon Semyonov, was sitting on his porch at the Vanavara trading post when, in his words, the sky split in two and a great fire appeared. He was thrown from his chair. The thermal pulse was strong enough to burn his shirt. 65 kilometers from the blast, window glass shattered in towns 600 kilometers away. A pressure wave traveled twice around the planet, recorded by barometers in London, Washington, and Jakarta. For weeks afterward, across northern Europe, the nights did not get dark. People in London read newspapers outdoors at midnight. In Stockholm, photographers took unsupported pictures of city streets at 1 in the morning. And yet, in St. Petersburg, the Imperial Russian Academy of Sciences did almost nothing. There was no expedition, no survey. The event was logged as a meteor, filed away and forgotten. The country had bigger concerns. In 9 years, the Tsar would be dead, the empire dissolved, and the question of what had really exploded in the Siberian sky would be left to a new state, a new generation, and a single obsessive man. Leonid Alexeyevich Kulik, mineralogist, curator at the St. Petersburg Mineralogical Museum. In 1921, while cataloguing meteorite reports for the new Soviet Academy of Sciences, he reread an old Krasnoyarsk newspaper clipping from July 1908. He became convinced that somewhere in the taiga there was a crater, and inside it, the largest iron meteorite ever recovered. It took him 6 years to organize a serious expedition. In 1927, after a 3-week journey by river barge and reindeer sled, he became the first scientist to reach the site. What he found rewrote the problem. There was no crater. There was no fragment. Instead, there was a roughly elliptical zone of devastation, 2,000 square kilometers across, in which every tree was flattened. The fallen trunks pointed radially outward from a central point, and at that central point, the trees were not flattened. They were standing upright, stripped of branches and bark, like a forest of telephone poles. A standing dead zone, surrounded by a wing of horizontal trees pointing in every direction away from it. Kulik called it the telegraph pole forest. He returned in 1929, 1930, 1938. He drilled the central swampland, looking for buried meteorite mass. He found none. He died on the Eastern Front in 1942, a prisoner of war, without ever having explained what made his radial pattern of broken trees. For Soviet science, the puzzle came down to one contradiction. The energy released was estimated at 10 to 15 megatons of TNT. That is roughly 1,000 times the Hiroshima bomb. Larger than any nuclear weapon detonated above ground before the Soviet Tsar bomber. An impact of that scale should have left a crater wider than the city of Moscow. There was no crater. The English meteorologist Francis Whipple proposed the first coherent answer in 1930. The object, he argued, had never reached the ground. It had exploded in the atmosphere. A meteor, or small comet, moving at 15 to 20 kilometers per second, would compress the air in front of it into a wall of plasma. At a certain altitude, the internal pressure would exceed the body's structural strength. It would fragment. The fragments would vaporize within milliseconds. The kinetic energy would be released as a pressure wave moving outward and downward from a point 5 to 10 kilometers above the surface. This explained the radial tree fall. It explained the telegraph pole forest at the center, where the pressure wave came straight down vertically. It explained the absence of a crater. It even explained the strange, luminous nights over Europe. A high-altitude cloud of ice particles, water vapor, and pulverized rock, lit by sunlight in the upper atmosphere. One thing it did not explain. What exactly had exploded? Stone? Iron? Ice? A comet? A meteoroid? Soviet science, for 60 years, could not decide. Into that gap rushed every theory the 20th century could produce. In 1946, the Soviet science fiction writer Alexander Kazantsev suggested it had been a nuclear-powered alien craft exploding to avoid civilian casualties. The idea would not go away for 50 years. In 1973, two physicists at the University of Texas, Albert Jackson and Michael Ryan, published a paper in Nature proposing that the object was a microscopic black hole passing through the Earth. The signature, they predicted, would be a second exit blast in the North Atlantic. None was found. In the 1980s, fringe theorists revived an older idea that Nikola Tesla, working on wireless energy transmission at Wardenclyffe in Long Island, had directed an experimental energy beam toward the Arctic to demonstrate the technology to the explorer Robert Peary. The beam, they claimed, had overshot and detonated above Siberia. There is no evidence Tesla ever attempted this, and his lab journals show no such test. The story persists anyway. The most scientific competing hypothesis came in 1999. An Italian team from the University of Bologna, led by Giuseppe Longo, identified an unusual lake 8 kilometers north northwest of the epicenter, Lake Cheko. They argued it was the impact crater of a surviving fragment. In 2020, an answer came from a completely different direction. By the late 2010s, supercomputer simulations of asteroid airbursts had become precise enough to invert the problem. Instead of guessing what hit Siberia in 1908, scientists could simulate every plausible candidate and compare the resulting treefall pattern, energy distribution, and atmospheric signature to the historical record. In February 2020, a team led by Mark Boslough at Sandia National Laboratories, with collaborators at NASA and Western University, published the most thorough reassessment to date. Their conclusion: the Tunguska object was not a comet. It was not iron. It was not a black hole, antimatter, or a misfired Tesla beam. It was a stony asteroid, approximately 50 to 60 meters in diameter, entering the atmosphere at about 15 kilometers per second at a shallow angle. The team's simulations showed that a body of this composition and size, decelerating against air pressure, would experience catastrophic fragmentation at an altitude of 5 to 10 kilometers. The fragmentation cascade would deposit 10 to 15 megatons of kinetic energy into the lower atmosphere in a downward-directed shock cone in under 2 seconds. The physical evidence supporting this is no longer just historical. On February 15, 2013, the same kind of event happened over Chelyabinsk, Russia, in front of 1,000 dashcam cameras. A 20-meter stony asteroid, airbursting at 23 kilometers altitude, 50 kilometers from a city of 1 million people. We finally had video of the mechanism that flattened Tunguska. The model survived peer review. The matter, as far as planetary defense is concerned, is settled. There is one detail that the 2020 paper underlined, and that the wireless beam and black hole theories never had to confront. Objects in the Tunguska size class, 50 meters, strike Earth approximately every 2 to 400 years. Most of them fall over ocean or empty land, and we never notice. The next one will not always have that courtesy. NASA's NEO Surveyor mission, scheduled for 2027, exists to find these objects before they find us.